Determine whether the following are perfect squares. If so, find the square root. 64 is a perfect square because 64, yes, is a perfect square because the square root of 64 is 8, since 8 squared is equal to 8 times 8, which is equal to 64. 36, yes, is a perfect square. The square root of 36 is 6, since 6 squared equals 6 times 6, which is equal to 36. 45 is not a perfect square. The square root of 45 is an irrational number, approximately 6.7082033932 ... which means and so on. These numbers will not repeat or terminate. It's an irrational number. X squared, yes, is a perfect square. The square root of x squared is x, since x times x is equal to x to the first power times x to the first power, which is equal to x to the 1 plus 1 power, which is equal to x squared. Remember, when we are multiplying numbers with the same base, we add our exponents. We could also say, which is a lot simpler, since the exponent 2 is even, we know it's a perfect square. Y to the 8th, for the same reason, we can say yes, it is a perfect square because the square root of y to the 8th is y to the 4th, since the exponent 8 is even. Remember, y to the 4th times y to the 4th is equal to y to the 4 plus 4 power, which is equal to y to the 8th. 4x to the 6th, yes, is a perfect square. The square root of 4x to the 6th is 2x cubed, since 2x cubed times 2x cubed is equal to 4x to the 3 plus 3 power, which is equal to 4x to the 6th. 9y to the 7th? No, it is not a perfect square, since the exponent 7 is odd. 49p to the 10th? Yes, it is a perfect square. 7p to the 5th is the square root, since 7p to the 5th times 7p to the 5th is equal to 49 times p to the 5 plus 5 power, which is equal to 49p to the 10th power. The learning objective for today, we're going to factor perfect square trinomials and the difference of two squares. This is going to be broken down into 3 10-minute videos. We'll start off by factoring a perfect square trinomial. Remember, anytime we have a trinomial in the form of a squared plus 2ab plus b squared, this is equal to a plus b squared. There's no work needed. You don't even have to write this intermediate step. So again, we go straight from here, straight to the answer. No work. So all these problems, no work. When we have them in the form of a squared minus 2ab plus b squared, again, we will be showing no work, going straight to answer. So let's take a look at one of the examples. We have x squared plus 12x plus 36. Notice that the x squared, this is a perfect square. The plus 36 is also a perfect square. Therefore, we can write it is equal to x plus 6 squared. Now, don't forget, you have to look at this middle term, and I'll explain that on the next slide. If we wanted to show work, 1 times 36 is 36. What two numbers multiply to give us 36 but add to give us 12? And that would be 6 and 6. So then we can write this as x plus 6 times x plus 6, which is x plus 6 squared. If we're trying to figure out whether this is a perfect square or not, the step 1 is we must try to always write it in standard form. That means descending order with respect to the exponent on the particular variable. In this case, the variable is x. We have x squared, that's a degree of 2, 12x, that's a degree of 1, and 36x to the 0 power, which is a degree of 0. Step number 2, verify the first and last terms of perfect squares. Plus 36, and remember, that has to be positive for it to be a perfect square. And we also, the square root of 36 is 6, so 36 is equal to 6 squared. And x squared is also a perfect square since it has an even power. The next step, we will take half of the middle term and square it. 12x divided by 2 is 6x. 6x squared is 36x squared. Step number 4, multiply the first and the last terms. X squared times 36 is equal to 36x squared. If the solution in step 3 and 4 are equal, the trinomial is a perfect square. If the solutions in step 3 and 4 are equal, the trinomial is a perfect square. As you can see, they are equal. Therefore, we could just write our answer, x plus 6 squared. This looks like it's a lot of work, but the more you do, the quicker you'll be able to recognize it, and you'll be able to do this rather quickly. But it's all about practice. So let's take a look at this one. Once I see this, I can tell it's a perfect square. So I know my answer is going to be x plus 5 squared. I take the square root of x squared, which is x. I take this plus sign down, plus, and then I take the square root of 25, which is 5. If I'm trying to look at it to see if it's a perfect square, the moment I multiply 1 times 25, I know that's 25. If you could take half of this middle term and square it and you get 25, then you know it's a perfect square. So that's what I kind of do in my head, and that's your mental math. Half of that, 10 is 5. 5 squared is 25, so it matches up. On the right-hand side, it's just a little bit more detailed because sometimes you have to worry about the variables. If the variables do not match up, you'll see in the next lesson that it may look like it's a perfect square, but perhaps this could be a cubed, or say this is a fourth and there's a y here, then it wouldn't be a perfect square. In this step, it's more detailed and it will give you 100% certainty that it is a perfect square. 10x divided by 2 is 5x, and when we square that, we get 25x squared. When we multiply the first term times the last term, we get 25x squared. Since they match up, I know it's a perfect square. Let's take a look at one with a subtraction. Again, once I look at this, I can tell it's a perfect square rather quickly. 1 times 49 is 49. Half of 14 is a -7, and -7 squared is equal to 49. A little bit more detailed explanation would be -14x divided by 2 is -7x squared is 49x squared. The first term times the last term will also give you 49x squared, so I know it's a perfect square.